Welcome, everyone, and Assalamu alaikum. Today, we are exploring the critical intersection of urban planning and global trade in our lecture, Sustainable Mobility and the Smart Port Nexus. Our focus is on modeling urban transport performance in Jakarta to enhance global logistics competitiveness. Why Jakarta? Because it perfectly encapsulates the ultimate modern challenge, bridging rapid, massive urban sprawl with the urgent need for sustainable infrastructure. Our method utilizes Advanced Geographic Information System, or GIS, spatial modeling to diagnose these systemic issues. Ultimately, our vision is to integrate urban hinterland efficiency directly with Indonesia's maritime future. As stewards of our cities, we must reimagine how goods and people move. To understand the solution, we must first confront the sheer scale of the challenge unfolding on Jakarta's streets every single day. Let's examine the Jakarta mobility crisis from a macro perspective. We are dealing with unprecedented urban density, over 10.37 million residents generating a staggering 21.9 million trips daily. Compounding this volume is a crippling 98% dependency on road traffic networks for regional transportation. Add to this extreme vehicle saturation, with over 13.3 million motorcycles sharing the exact same corridors as heavy freight and passenger vehicles. The result? A severe logistics bottleneck where average speeds in critical zones are plummeting below 10 to 20 kilometers per hour. This isn't just a daily inconvenience. It is a structural failure that strangles economic vitality and environmental health. How do we untangle a web this complex? We need precise, data-driven objectives to decode this urban sustainability puzzle. Our research objectives are designed to move us from broad observation to actionable spatial intelligence. Objective 1 focuses on performance identification. We establish and map baseline sustainable transport indicators across 42 distinct urban districts. Objective 2 shifts to quantitative measurement, where we calculate a unified sustainable urban transport performance index, which we call SUTPI. Finally, Objective 3 involves predictive modeling, utilizing spatial regressions to decode the complex relationships between variables and forecast future performance. By structuring our research this way, we shift from treating surface symptoms to diagnosing the underlying infrastructure disease. Let's dive a bit deeper into the analytical engine driving this research, our GIS diagnostic framework. Methodology is everything in spatial science. We built a robust GIS diagnostic framework to translate raw data into spatial realities. First, data transformation. We convert standard key performance indicators into spatially mapped spatial performance indicators, or SPIs. Next is spatial classification, where we stratify district-level data onto a precise 5-tier scale, ranging from high to low. Then, we move to composite indexing, carefully weighting these variables to generate that singular SUTPI metric. Finally, we apply geographically weighted regression, or GWR. This allows us to apply local regressions to isolate the unique, hyper-local spatial dynamics of each specific district rather than relying on global averages. But what exactly are we measuring? Let's unpack the 5 core pillars defining transport sustainability in our model. A holistic view of urban sustainability requires us to measure multiple interacting dimensions. We identified 5 pillars of transport sustainability. First, traffic accidents hold the highest weight at 30%, measuring absolute incident frequency per district area. The preservation of human life must always be paramount. Traffic congestion and air pollution, AQI, each carry a 25% weight. Here, we map the spatial density of severe congestion points and track daily emissions via traffic flow models. Finally, noise pollution and land consumption both carry a 10% weight, factoring in acoustic buffering indices and the ratio of transport infrastructure to total district area. When we applied these 5 pillars across Jakarta's grid, the spatial mapping revealed a stark and polarized reality. Our major findings exposed severe spatial performance disparities across the city. Overall, we found a state of systemic mediocrity, with the global average for Jakarta sitting at a medium sustainability level of just 2.95, while 13.7% of districts achieve high performance, mostly scattered across the central, west, and south peripheries. The alarm bells are ringing elsewhere. The critical zones, representing 18.3% of the area, show low performance and are tightly clustered in the north and east. This polarization effect proves that blanket, citywide policies will fail. We absolutely must demand localized, targeted interventions to fix these disparities. Let's zoom in on the most critical of these failing zones, the North Jakarta Freight Nexus, where urban life meets global trade. North Jakarta is the logistics epicenter of the nation, hosting the massive Tanjung Priok International Port. However, this area suffers from what we term compounding failures. High concentrations of heavy freight cause severe spikes in both congestion and noise pollution coefficients. Furthermore, these northeast districts act as primary emissions gateways, funneling heavy traffic and severely degrading overall AQI levels. The implication here stretches far beyond local public health. These urban bottlenecks directly degrade national maritime turnaround times and overall trade efficiency. We cannot have a world-class port choked by a struggling host city. Knowing the current state is critical, but we must also look ahead. What does our modeling tell us about the future if we maintain the status quo? Our predictive modeling paints a highly concerning picture of our future trajectory. Our GWR model has high explanatory power, robustly accounting for 84.5% of the variability in sustainable transport performance. Unfortunately, the predictive mapping reveals a definitive negative trend, a forecasted decrease in overall sustainable transport performance across the entire metropolis. We are facing what I call shrinking excellence. The districts currently maintaining a high performance are projected to drop dramatically from 13.76% down to just 11.04%. Without immediate, structural intervention, the network will continue to degrade. This looming decline brings us to the most crucial part of our discussion. How do we actively intervene using spatial intelligence? The data demands targeted spatial policies over political guesswork. We must utilize strategic allocation, funding specific solutions strictly where their spatial coefficients guarantee the highest mathematical impact. For the Northeast interventions, this means prioritizing port-bound traffic management and heavy rail freight integration to finally reduce severe congestion. In the Southwest, the focus must shift to aggressive accident reduction strategies and road safety infrastructure where those coefficients peak. Finally, in the southern districts, we need to constrain excessive land consumption for traditional roads and urgently pivot to intelligent transport systems, or ITS. By implementing these targeted urban policies, we can begin to repair the vital bridge between city logistics and national maritime success. We must focus on bridging urban mobility with national logistics. First, we must recognize the urban hinterland. A smart port is only as efficient as the urban transport network feeding it. Second is digital synchronization. We need to seamlessly synchronize city traffic data directly with maritime terminal operating systems to eliminate blind spots. Third, we drive maritime competitiveness by decarbonizing supply chains. Reducing urban idling directly lowers the carbon footprint of the crucial first and last miles of global shipping. Ultimately, we must move beyond the road, shifting from 98% road dependency toward a multimodal, digital-first freight ecosystem. As we look to the horizon, the path forward for Jakarta, and indeed all global port cities, becomes remarkably clear. The maritime horizon depends entirely on a sustainable future. The bedrock principle we must accept is that urban transport sustainability is the absolute foundation of maritime competitiveness. We must cultivate smart port synergies, where AI and IoT seamlessly connect city logistics with maritime infrastructure. Furthermore, sustainable expansion is non-negotiable. Prioritizing green hinterland corridors protects public health while simultaneously supercharging trade efficiency. This is Indonesia's global edge. By leveraging precise spatial data, we can transform a crippling traffic crisis into a world-class, digitized supply chain. Thank you all for joining me in building this sustainable vision. Wassalamualaikum.